vacuum cleaners. They circled the sun.
Okay, I don't know why it jumped back to that one. All right, here we go. Yes.
Did you give us things to choose for the king and queen or whatever?
I didn't have them, so I got to find out who has them because they weren't in my box this morning. Okay, I'll get them from her. Are we ready?
Dear Tim and Moby, what's the Earth made of anyway? From K.L. Helly. Well, there is a lot of metal in the Earth, along with silicon-based rock. How do we know? Earthquakes. Like any other waves, earthquake waves bend when they travel through different materials. By studying the way earthquakes vibrate through the interior of the planet, scientists have been able to get a pretty good idea of Earth's internal structure. Yikes. The Earth has three basic layers: the core, the mantle, and the crust. The crust is the part of the Earth we live on. We can only see the very top layer of the crust. Underneath all that grass and dirt and sand and water and stuff is a layer of hard rock. The crust is about 5 to 10 kilometers thick in the ocean basins and 35 to 70 kilometers thick in the continents. Below the crust, you'll find the mantle. The mantle is made up of a mixture of elements including silicon, iron, magnesium, and oxygen. It goes down from the bottom of the crust to about 2,900 kilometers deep, and heat churns through it. The mantle makes up the bulk of the Earth's mass, about 2/3 of it, in fact. Parts of the upper mantle are soft and plastic. This is what allows the tectonic plates that make up the Earth's surface to move around. The lower mantle is solid and extremely hot. At the very center of the Earth, you'll find the core. The outer core is Earth's only totally liquid layer. It's about 2,300 kilometers thick and made of molten iron and nickel. The pressure from all those other layers pushing down creates a solid ball in the very center of Earth called the inner core. It's made of mostly iron, and it can be found somewhere around 5,100 kilometers below the surface. The inner core floats in the outer core and spins at a different rate than the rest of the planet. This, along with the convection currents in the mantle, is probably what causes Earth's magnetic field. Well, nobody knows this stuff for sure. The deepest hole ever drilled was only about 12 kilometers deep. That's only a tiny fraction of the 6,355 kilometers to the center of the Earth. Okay, but I'm telling you, it's going to take a long time to get to the core. I'll call you when dinner's ready.
What did it say was the deepest hole ever? I didn't really catch a lot of that.
I didn't get the. Wait. I didn't do.
All right, number one, how do we know what the inside of the Earth is made of? Okay, we use earthquake data to figure that out. 2, what are the 3 basic layers of the Earth?
Core, mantle, and crust.
Core, mantle, and crust. 3, list several facts about Earth's crust below. Were you able to get anything?
I got one.
It's hard rock. It's 5 to 10 kilometers thick.
We live on it, and we can only see the top layer, and it's 5 to 10 kilometers deep or long or whatever.
Okay, so the 4 that I got yesterday, just to clarify, it's the part of the Earth we live on. It's a layer of hard rock. It is 5 to 10 kilometers thick in the ocean basins, and it's 35 to 70 kilometers thick under the continents. Is that good? Sorry? 35 to 70 kilometers thick under continents.
So why in some places thicker than others?
We're going to learn there are 2 kinds of crust, oceanic and continental, and they're made of different material. But the continental crust is thicker because it's older, and it's how mountains form and stuff like that, where it starts piling on top. And oceanic crust is younger; it's newer. Okay, facts about the mantle, number 4.
It's made of silicone. Iron makes up 2/3 of the Earth's mass.
Okay. The ones I got is it's a mixture of elements. It's 2,900 kilometers deep. Heat churns through it, and it's 2/3 of Earth's mass. That was number 4. Anybody need a repeat? Are we good? Repeat? Okay. A mixture of elements, 2,900 kilometers deep. Heat churns through it, and it's 2/3 of the Earth's mass. Okay, 5. List several facts about Earth's core.
Wait, what is the abbreviation for?
Oh, kilometers. You good? Okay. 5. List several facts about Earth's core. There's an outer and an inner core.
It's one of them's liquid and one is solid. And then the inner core spins at a different rate than the rest of the Earth,
Okay.
which causes gravity.
So I'll repeat what I had just so if you need one. For number 5, list several facts about Earth's core. The outer layer is molten. It is made of iron and nickel. It is 5,100 kilometers below the surface. And the inner core spins inside the outer core.
So does that mean the Earth, like, if we were gonna dig to China, we'd have to dig like 12,000 kilometers?
It'd be more than that, right? Because it's 2,900 and 5,100. Or it's 5,100 where the core starts. So yeah, I guess if you were going to come out on the other side,
Yeah,
it'd be 12,000.
about 12,000.
Why is it so hot in the core? Is it like friction or did it like not cool down?
It's so much pressure from all the stuff on top of it that it causes it to heat up. Are we ready for 6?
Yeah.
Yeah.
Okay, what causes Earth's magnetic field?
The core spinning at a different rate than the rest of the Earth.
Yeah, the core spinning at a different rate. 7. What is the deepest hole ever dug? 12 kilometers. Okay, here's the problem with us not being able to get to Brain Pop. The rest of these are in like the related reading on Brain Pop, so I'm just going to tell you what you would have read if it had been available. So for number 8, arts and entertainment. What were some of the science inaccuracies in the movie The Core? Has anybody seen it? Okay, one of the inaccuracies is they said the mantle was liquid. Another one, they had a character that survived falling in 9,000 degree liquid. So someone survived falling into the mantle.
But the mantle's not liquid.
That's the inaccuracy. And lightning disintegrated a building.
Is this
Lightning.
like a science fiction movie?
Yes.
Some of this stuff, I'm like, why would you have lightning disintegrate?
Is everybody good on 8? Okay, 9. Graph, stats, and numbers list 5 elements that make up Earth's crust. I'm going to list them all. You can do 5, you can do them all. So, oxygen, silicone, aluminum, iron, calcium, sodium, potassium, and magnesium.
Don't we have a lot of those, like, that body, like sodium, potassium, magnesium.
What's wrong?
I don't know how to spell.
Okay, you want the abbreviations?
Sure.
Okay, so the element symbols for these are O, Si, Al, Fe, Ca, Na, K, and Mg. Better?
Yes.
All right, 10. Has anybody read Journey to the Center of the Earth? Has anybody seen the movie?
I've heard of it, and I've been meaning to watch it, but I just haven't.
Okay, so Journey to the Center of the Earth. What did the author Jules Verne think was inside the Earth? He thought there would be dinosaurs.
Oh yeah.
He thought there would be underground oceans. And he thought there would be enormous prehistoric humans.
I've seen the second Journey to the Center of the Earth too,
I have not seen that one.
but I haven't seen the first. We watched it in this passion.
Oh yeah.
I haven't seen the first one, although I do have it on DVD.
Okay, 11. What is the Kola Super Deep Borehole? What urban myth was spread about it? Are we struggling today?
Yeah, it's complicated.
Okay, the Kola Super Deep Borehole is the world's deepest hole near the Arctic Circle. It's the world's deepest hole near the Arctic Circle. They said 12 kilometers, right? And the urban myth was that the Soviets recorded wailing human voices, so they thought that they recorded wailing human voices, so they thought that there was an underground population. WAILING. It happens, right?
Look up a quiz and play the review and let your score down.
Yeah, we can't do the quiz. Have you?
Like, some, and I also heard like some people think it's like hell.
Yeah.
So.
Okay. You can't do the quiz because we can't get to Brain Pop, and you can't do the Time Zone X icon. So look at your layers of Earth. The top layer would be what? The crust. And they divided it into 5 instead of 4. So instead of one mantle, you have upper and lower, yes. And then, yeah, your core is outer and inner. So hang on to this in your notebook so you have it to study from. Let's talk about Earth.
Can I hold punch on when I get done, right?
Yes. Sorry? Yeah, outer core and inner core. Okay. So the picture is called the Blue Marble and was taken by the astronauts of Apollo 17.
Is that the last Apollo mission?
I think. But I'll have to look. How do we know Earth is round? We've talked about this.
Yeah, see pictures from space.
Okay, we see pictures from space.
Shadow.
Shadows. Satellite. When you see a boat floating away from you, it disappears, right? Over the horizon. Anything else? We did the lab for this, right?
Yeah.
Or I mean, hey, the Earth is flat and it's soft.
People are starting to navigate the Arctic. So
If it was flat, yeah. when it disappears over the horizon.
So ours has been circumnavigated before. Therefore, meaning if we tried to circumnavigate a flat Earth, we'd fall off the end.
Yeah. Or just keep going and going and going.
Yeah.
Okay. Have you talked about hemispheres with Coach Steve?
No.
Alright. We talked about the shape of Earth is technically spherical, but we call it an oblate spheroid. But can it be divided in half?
Yeah.
Yeah, you could slice it in half, right? Hemisphere is a half of a sphere. So we divide Earth into north, south, east, and west hemispheres. Familiar with this?
Yeah. Well, they all.
Yeah, they all overlap. So if the equator is 0 for northern and southern, and the prime meridian is 0 for eastern and western, where are we?
We would be in the northwestern hemisphere.
We're in the north and the west, right? Okay, if you don't know that, look at your latitude and longitude. You're in the north and the west. How do you know Earth rotates?
Because the sun and the moon rise from different sides.
Okay, the sun and the moon appear to rise, right?
Yeah.
The sun rises in the east and sets in the west.
And the moon rises.
Are we familiar with this?
Yes.
Okay. Earth rotates on its axis, so it appears that the sun moves through the sky in the day, but the sun's not moving, we are, correct?
Yes.
Okay. So this creates day and night. Our axis of rotation, if you imagine a line going through the center of Earth, right? That is your axis. The North and the South Pole are connected by that imaginary line. Our axis of rotation is tilted. Do you know how much?
27 point something degrees.
It's like 23.5. It changed when the earthquake happened in Indonesia a few years ago. Which shifted a little bit on our axis. So Earth spins on the axis or rotates every 24 hours. How many hours are in a day? 24. If you look from the North Pole down, it looks like the Earth is rotating counterclockwise. The sun, moon, stars appear to rise in the east and set in the west. So if you thought that the moon rises in the west, that's not correct. The sun and the moon rise in the east and set in the west. The cycle of light and darkness every 24 hours is our day, correct? Is it the same on every planet? No. And sunrise, sunset, and day length differ by location. All right, what is March 21st?
That would be the spring solstice, 12 hours of daylight.
That summer is the solstice. What is the spring? It's the equinox, right?
Oh.
We have a fall and spring equinox and a summer and winter solstice.
And
Okay.
the equinox is at 12 hours of daylight, 12 hours of darkness.
At where? At the equator.
At the equator.
We don't get direct light here, correct?
No.
We get angled light. Our days start to get longer, though. Our days are getting longer now. Can you tell?
Yes, because the winter is the most amount of darkness and the least amount of
Yeah, the shortest day of the year is December 21st. So Earth revolves. Okay, Jupiter's moons revolve. The Earth orbits the sun. So if you look, you can see the moons on Jupiter. See the little dots? They're not visible at all times. Why?
Because they could be behind them.
They could be behind Jupiter when they're revolving, right?
Does okay, so our moon it makes the Earth it's not just the moon, but it makes our Earth dark at night.
The moon doesn't have light of its own. It reflects sunlight. So
does other moons do the same thing?
So our moon, I know our moon rotates, and it revolves around Earth, but it also rotates on its axis.
yes,
But I looked it up, and did you know we only see the one side of the moon
yes,
because of the way it,
because of our rotation.
which I thought was interesting.
So the Earth orbits a star, which is our sun, correct? So if you are not familiar with this, why do we have leap year?
Because it's 365 and a quarter day.
Okay, so each year is 365 and 1/4 days. Every 4 years we add that day to balance that time back out.
Is that a typo, or is it actually a little less than a quarter of a day?
That's pretty close.
Okay.
That was the number that I found.
Okay.
So we orbit because of the sun's gravity, and our orbit is slightly elliptical. We talked about this a couple weeks ago too. When are we closest to the sun?
And winter.
We're closest in winter, and we are farthest away in summer. So what gives us seasons?
Our axis.
The tilt on the axis, yeah.
If we're closer during the winter, why is it so hot in the summer?
Because in the winter we're tilted away from the sun, and in the summer we're tilted toward the sun. So even though we're closer, we're angled away. Yeah, Australia's in summer right now. So the distance between the Earth and the Sun is 93 million miles, and Mercury and Venus are closer, so their orbit is faster. They have less distance to cover, correct?
Yep.
All right.
So we were watching the show and they were like in Australia and they like reached like 18 degrees Celsius during summer, which is they reached like 32 degrees Celsius, which is like 118 Fahrenheit.
In California, they hold the world record for the hottest temperature on Earth with 138 degrees.
Death Valley.
Yeah. We went out there and it was 137. They said it was on the verge of breaking the record. The hottest.
Well, and like a few miles down the road is
In
Mount
33.
Whitney, and it's below 32 in the summer. So
Yeah. It's kind of strange there.
they have an Ironman race that goes from Death Valley to the top of Mount Whitney. I think it's like 72 hours they have to go from one to
That
the
would be
other.
a hard race though. It's
It
like
would be.
going from all of that oxygen you have down below sea level to having almost nothing at the top of a mountain.
All right, is everybody with me? Because we seem to be having some little side conversations. There is some misunderstanding. We just talked about this, that the Earth is closer to the sun in the summer. It is actually closer in the winter. So the difference in the seasons in the northern and southern hemisphere, remember they're reversed. If we're winter here, they're summer in the southern hemisphere. We are tilted at 23.5 degrees. So one hemisphere is always pointed to the sun. The other hemisphere is always pointed away. The axis always stays lined up with the North Star. So our summer, we are northern hemisphere, correct? We talked about that a minute ago. The North Pole is pointed toward the sun, so the sun's rays strike more directly. And you can see the way this is tilted. The sun is hitting more directly on the top half, correct? Okay, the summer solstice is June 21st or 22nd, depending on if it's a leap year. That means the sun's rays are directly over the Tropic of Cancer. So that is the farthest north that the sun will be directly overhead. The winter solstice would happen in the southern hemisphere. Then we flip, right? The axis tilts the other direction. So winter solstice is December 21st or 22nd, depending if it's leap year. The North Pole points away from the sun, so the light gets spread out over a larger area. If you pay attention to this in the winter, you'll see the shadows are longer because that light is hitting at a different angle. So there are fewer daylight hours in winter and less time for the sun to warm. And that doesn't mean that the day actually changes from 24 hours. Do we understand that?
It just means it's darker.
It just means it's darker for a larger portion of the day, yeah. So if it's winter in the north, it's summer in the south. The equinox is that halfway date between the solstices, and I said it's September and March. Okay, September is the autumnal, September 22nd or 23rd. The vernal is March 21st or 22nd. This is when the sun's rays shine most directly on the equator. So this would be like 12 hours of daylight, 12 hours of dark. What about if you lived in Alaska?
It would probably still be dark.
You have like 3 hours of daylight for part of the year, right? And that's all you get.
Some parts of the year, don't you? Isn't it dark for like 4 days in Alaska?
It's when I went in the summer, it was dark for 3 hours every night.
Yeah.
You would get up to go to the bathroom at like 3 o'clock in the morning, and it would be like bright outside.
And then I watched a video and somebody was on vacation in Alaska, and it was in like January, like late December, early January, and they
And it's
said,
dark.
yeah, you're like, they said they might have been lucky to get a little bit of light in the middle of the day.
Yeah.
And there's 4 days out of the year where it's like that, and then you start getting like 30 minutes of daylight.
Yeah. Okay, so how deep can we drill into Earth's interior? The video talked about this, right?
It says
Cola
12
borehole.
kilometers, but that says 10 kilometers. Picture says 10 kilometers.
The picture says 10 kilometers. This is a Russian stamp that they did to commemorate. Maybe they rounded it. I don't know. So the Kola super deep borehole, to give you an idea of how much 12 kilometers is 40,230 feet. How many miles is that?
That's like a little less than. It's like 7. It's a little less than
7
7.
something, right?
Said 20.
5,280 feet in a mile.
5,000. I did 2,000.
It's about 6.5.
So like we only have like so many kilometers of like the crust.
Uh-huh.
So like with as much as like people dig and stuff like that, like we can't like we can produce dirt, but like not like enough for like, the earth. So like, is it possible that like billions of years in the future that like we could like reach like the end of the crust?
If we had the tools to do it, but that's the problem. The temperature and the pressure get so high that it like breaks the drill bits.
Our material.
But 7 miles is pretty deep, right?
It is. And why did they even dig a hole that deep?
I'm guessing it had something to do with mining to see what they could find that far down, but I'm not really sure.
Because I mean, it would seem like a waste of time unless they would purpose. A waste of time and money.
I'm guessing it was probably for a mine.
And if it's in Russia, they have a lot of coal up there.
They do.
In Russia,
So learning about Earth's structure requires less direct methods because we cannot get more than a third into the crust. How can we figure out what's inside our planet, and how do scientists figure it out?
Earthquakes.
Okay, they look at earthquake data, seismic waves, which are earthquake waves. Do we like studying about earthquakes?
They're confusing, but they're interesting.
That's one of my favorite things to learn about. We're coming up on that pretty soon. When an earthquake happens, wherever the focus is, Earth is a sphere, right?
Yeah.
So if you drop a pebble in a pond, where does all the waves go?
They go toward the outside.
They go all directions, right? Same thing happens when we have an earthquake. Okay, waves from that earthquake go in all directions. Seismic waves have different speeds through different materials. We've talked about that. When a wave hits a liquid from a gas, does it speed up or slow down?
It slows down. It's not.
It speeds up.
I thought it like going from a liquid to a gas.
Liquid to gas, it will slow down.
Oh,
Gas to
I
liquid, it
thought
will
that's what
speed
you
up.
were asking.
The closer the particles are, remember, the faster that wave can move, okay? So the seismic wave speed changes when that wave passes from one type of material to another and the wave bends. This was an ACT question a few years ago.
ACT question.
Uh-huh.
We covered that at the beginning of this year.
The ACT?
Oh no, the question about the earth.
Waves? Yeah.
Yes. Why would that be on the ACT?
They give you a picture of an Earth and they show you some waves passing through and they ask about wave speed and what happens when it changes from one medium to another. I saw it on the practice test, the release practice test. So some waves are stopped by liquids or gases. Okay, some waves can't pass through certain materials. We learn about this from meteorites. So any fairly small object from interplanetary space. Can an asteroid be a meteorite?
No. It's not.
Yes.
It is. Some of them are small.
So what defines an asteroid, a meteorite, and then a
It's
comet?
a very fine line. Asteroids and meteorites are basically the same thing. Comets are more ice, so they have a little different structure. But it's a very fine line between what's what. So we study this to learn about Earth's interior because where do these come from?
Space.
Where in space?
Deep space.
Well, there's leftovers from the
Where is
Big
it?
Bang.
The meteor.
The asteroid belt.
Kuiper Belt, yeah.
In between Mars and Saturn.
The Kuiper Belt between Mars and Saturn. These come to us from there, and we think this is old material that we can look at to see what early stuff was available.
Leftovers from the Big Bang.
Some of these are made of iron and nickel, so they are similar to the core. Other properties. Okay, Earth's overall density. So if you look at a density for Earth, it's higher than the density of the crust. So we know the core has to be made of something more dense. Have we ever seen the core? No. Have we ever sampled the core? No. We know there's a magnetic field because Earth is a magnet, right?
Is the core like as hot as the sun?
Probably not as hot, but I don't know that we know because we can't really measure.
And let me just take my temperature gun.
Yeah, take your temperature gun.
The core is coated.
The core is covered.
I mean, seeing as its temperature would be over 1,000,
It would be over 100.4, right?
I assume we wouldn't want it in our building.
We know about the magnetism because we know iron, nickel, and what's the other one are magnetic?
Aluminum.
Cobalt, yeah.
I'm a fault.
So the outer layers on the surface is where we live, true?
Yes.
All right. So we know there are gases because we breathe oxygen and other gases. We know there's water, rock, living organisms. Those materials are also found below the surface. And those materials interact and change each other. So have you heard of the hydrosphere?
No.
I've heard of it, but I couldn't tell you what it is.
Okay, we're going to talk about the spheres. So the atmosphere is the gas layer on top of Earth. This is what we breathe, right? And this is what protects us from space debris. It's mostly nitrogen and oxygen. There's a little other stuff mixed in. The hydrosphere is all the water, and that includes frozen water. Okay? Sometimes you hear it called the hydrosphere cryosphere, because what does cryo mean? Ice, yeah, frozen.
Oh, that makes sense. Hydro's water.
Hydro is water. The biosphere is all living things. The lithosphere is the solid rock part. And that includes mountains, valleys, continents, anything under the ocean that's rock. So there's constant interaction between the spheres. Does that make sense? Earth is a system, true?
Yep.
So I've got my essay written, and I've been working on it for about a week.
ads.
So now I'm going to show you how I use Grammarly to edit.
Why are all the ads?
All right, we're talking about the four spheres of the Earth today. In this tutorial, we're going to talk about the atmosphere, hydrosphere, lithosphere, and biosphere. Let's talk about the atmosphere first. The atmosphere is basically all the gases surrounding the Earth. So when I talk about that, I mean, okay, here's a nice picture of the Earth from space. There's the surface of the Earth all the way up to this point where you can't really see anything anymore. And that's the atmosphere. Okay? Gases that we can't normally see. The atmosphere is where weather happens. Whenever we have storms or rain or anything, the atmosphere is where this is occurring in. Wind currents are a big deal with the atmosphere because they transport things like clouds a long distance. Okay, if we didn't have that, then most of the Earth would be a desert. Since we're talking about a little bit of that, the atmosphere spreads that water through the water cycle. We remember that the water cycle is basically the sun's rays pounding the Earth with energy, making things hot. When water in its liquid form is heated up, whether it's in the soil, in oceans, or in lakes, it will tend to rise. That is called evaporation. Once that water vapor rises up in the atmosphere high enough, it'll start to condense into clouds. And as that condensation increases, pretty soon you have a nice big cloud here, and that water vapor will return to its liquid form in the form of precipitation, which is rain, snow, sleet, or hail. All right, let's talk about the hydrosphere now. It's all the water in the world, all of it. I mean rivers, I mean lakes, I mean oceans. Now, the big deal with that is that we have ocean currents as well. Ocean currents will transport warm and cool water all around the globe. It's basically the heating and cooling system of the Earth. Let me get back down here. All right, now the water cycle is also not just how water is transported, but how the hydrosphere changes. Okay, in oceans and lakes, it's liquid. As it evaporates, it is gas. As it condenses, it turns back into its liquid form. All right. Now that we have that all with, let's talk about the lithosphere. Lithosphere, it's the Earth's crust, what we walk on. It's what our rocks are made of and stuff. So we can see the lithosphere is this tiny little skin that surrounds the Earth, kind of like an apple. Has a thin layer of skin, but all this kind of crazy, good-looking stuff inside here. All this is inside here. This would be liquid hot magma. Don't touch this. Tectonic plates are a part of the lithosphere. They create mountains, valleys, volcanoes, even oceans. When those tectonic plates separate, they create oceans. Wow, isn't that cool? Okay, now another important thing about the lithosphere is that over time, the rocks that are a part of the lithosphere can be turned into soil. We have weathering processes such as rain falling down on this big rock, wind blowing this rock around, maybe freezing and thawing forces. All of those will separate little bits and pieces of this rock at a time. And we can see down here at the bottom of it, those little bits and pieces of rock is deposited at the bottom. This will be eventually turned into soil. All right. Erosion over time turns rocks into soil. Now, the biosphere, since we're talking about soil, let's transition right into plants and animals. Biosphere is all the plants and animals in the world. All these different plants, all these different animals, and of course we see as a wonderful backdrop, the soil, which we just talked about as the lithosphere. Okay, that's how these things are kind of connected. The soil in the lithosphere brings forth life in the form of plants, which also allow animals to exist. And then you have there are forces such as the atmosphere and hydrosphere, all interacting to bring life to this earth. Oh, how nice. Okay, that's the four spheres.
You booked a Sunny Verbo ski chalet.
No, I didn't.
Sorry?
It said you booked a Sunny Barbo ski shop, and I said no, I didn't.
Oh. Okay, so that was outer layers, inner layers. You have inner core, outer core, mantle, crust. If you can slice it in half. So the lithosphere is brittle. What does that mean?
It's hard to eat.
Yeah, it's hard. If you hit it, it'll crack, right? Okay. Riding on the plastic asthenosphere. Okay, so part of the mantle is melted. If you can imagine, like, when you melt plastic, what does it look like?
It looks like melted butter.
It looks liquid, right?
Yeah.
And it looks kind of warped. So if you can imagine part of the mantle being kind of melted and warped, the pieces of lithosphere float on top of the asthenosphere. The core, divided by composition, the crust is core, mantle, and crust divided by composition. The crust is less than 1% by mass. So the crust is very light. You can have oceanic crust. You can have continental crust. Then the mantle is hot, dense, and dark. It is called ultramafic rock. That just means it's dark. And it is 68% of the mass. And then the core is mostly iron. That is 31% of the mass, and it's 2 layers.
Hey, I'm just making a planet. Well, this is how planets like Earth get their structure anyway, because of different layers of density. Even today, with all of our modern technology, we've only been able to drill about a third of the way through Earth's crust. So, how do we really know if it's solid, liquid, hollow? Luckily, Earth has this tendency to violently shake and occasionally burp up some of its insides. And that's taught us a lot about our planet's guts without having to go down there. We're used to seeing density at work. That's the same reason that the atmosphere, the least dense part of our planet, is on the outside. And the crust, the second least dense part of the Earth, is beneath our feet. Because I'm less dense than the dirt, I don't sink into the ground. And even though there's about 1 ton of atmosphere above my head, it's not dense enough to send me floating. The main layers of the Earth are organized in the same way. Depending on whether they're divided up by how they squish around or what they're made of, geologists give different names to the different layers of the Earth. So that's how it is now. But to really understand why the Earth is organized the way it is, we need to go back to before our planet even existed. In the very young universe, hydrogen and helium were pretty much the only elements around. They condensed into stars, began the process of nuclear fusion, and eventually died, spitting heavier elements from carbon and oxygen to things like nickel and gold back out into the universe. One of those heavy elements, iron, is the most stable element produced outside of a supernova, and the early universe produced a lot of iron. That'll be important in a second. Fresh hydrogen and helium went on to form new stars like our sun, and the heavier elements collided to form the dust and debris that would become our solar system's planets, and moons, and asteroids, and everything else. High temperatures in the early inner solar system meant that light volatile elements could only condense further out, which is why the 4 inner planets of our solar system are dense and rocky, while outer gas giants like Saturn could hypothetically float in a really big swimming pool. After proto-Earth grew larger, radioactivity, gravity, and violent boom booms melted that messy mixture of rocks and minerals, and this is where things started to get organized. Just like that tower of density, the heaviest materials like iron and nickel worked their way to the core. The lighter materials like aluminum and silicon stayed near the surface. The inner core experiences pressures more than 3 million times what we do on Earth's surface, which means that despite being as hot as the surface of the sun, the iron in our planet's inner sphere is likely solid and not liquid. The outer core is most likely liquid because it's hot, but not under as much pressure as the inner core. We know that's the case because of earthquakes up here on the surface. As certain kinds of seismic waves travel through the Earth, the liquid outer core either refracts them or blocks them altogether. That creates seismic shadows on the opposite side of the planet. If you want to use pressure to melt metal at home, just stack up 16 million pennies. The one on the bottom should liquefy in no time. Mercury is so close to the sun that its atmosphere has long since blown away. But luckily for you and me, our liquid metal outer core lets us have an atmosphere. Deep metallic convection currents create a magnetic field that shields Earth from the solar wind. Otherwise, we'd be pounded with deadly radiation, our atmosphere would be blown away, and Earth really wouldn't be a very lifey place. Over time, Earth continues to cool, so more and more of its liquid outer core is turning solid, and we're shrinking little by little. Every earthquake that we feel is Earth taking one step closer to cooling off and becoming a real third rock from the sun. So there you have it. Like Carl Sagan said, we are star stuff who has taken its density into its own hands. It's density, right?
I'm your density.
Stay curious. People have been looking at clouds since people have been people. Those billowing shape.
You guys don't know the Back to the Future reference, do you? You don't know the Back to the Future reference, do you?
I think I do, yeah. I think Back to the Future, but it's kind of hot.
He's trying to tell her that he's her destiny, and he tells her that he's her density.
Oh, yeah.
Yes, I am your density.
Yeah. Okay, so we have division by composition. We have division by mechanical properties. This got into our lab with the clay, right?
Yep.
Okay, you had more layers in that lab. The lithosphere takes the crust and part of the mantle. Brittle, rigid, solid, and easily cracked or broken. This is your tectonic plates. Are we familiar with tectonic plates?
Yeah.
Okay. The asthenosphere is upper mantle. It is below the lithosphere. It is solid, but it is plastic, sort of, in its description. It's kind of like silly putty. Okay? It can bend, it can float. Both of these pictures are Earth's crust. The left is continental crust. The right is oceanic crust. Continental crust is old. Oceanic crust is new. The crust, mantle, and core we know have different composition. We know the most about the crust. Why?
Because we're standing on
Because we live on it, right? We see it all the time. We're familiar with it.
it. Easy to get a hold of.
Where the water?
Which water?
All the water. Like, how did it?
How did I get here?
Yeah.
So the video that we watched a couple weeks ago talks about comets. Probably brought it.
A lot of comments.
It would be a lot of comments, yeah. Crust is thinner under the oceans because it is newer, thicker under mountain ranges because it is older. So oceanic crust looks like this. It is darker. It is caused by a rock called basalt. We haven't learned about rocks yet, right? What y'all working on your Chromebooks? Just out of curiosity. That's what I thought. Oceanic crust is pretty thin because it's forming. It's new stuff. It's not going to be very thick. It's not going to be very sturdy. The rocks that make oceanic crust are denser. So when oceanic crust and continental crust come together, which one's going to sink and which one's going to rise? Oceanic's going to sink and continental's going to rise because of that density difference. We're going to talk about that when we talk about plate tectonics. Continental crust is a lot thicker. It is about 35 kilometers thick on average, but it varies a lot. How tall is Mount Everest?
A lot. Like, mine's at
24,000 feet.
It's several miles, right? So it's really thick right there. And it's also underneath. Like, you have to have the kernel of a mountain underneath the mountain. So in addition to what you see, there's like more stuff underneath.
That keeps it.
That keeps it from tilting over. They're made of different rocks. So you can have igneous, metamorphic, and sedimentary. Familiar with those? Yes, no, maybe? Yes? It is, on average, less dense. And it does rise higher above the mountain.
I'm Dr. Jeff Innicker, and today we'll explore the science of weathering and erosion.
The Differences of Oceanic and Continental by Tate and David.
There are 6 differences between the continental and oceanic crust. The continental is less dense than the oceanic.
The continental is thicker, but the oceanic is thinner.
The continental is lighter colored than the oceanic.
Continental floats on magma better, and then oceanic can flow on not that good.
The continental cannot recycle while the oceanic can.
And then the continental one is older, but the oceanic one's younger because of the magma pushing up. But then the same of them are both crust, and then also they're both on mantle. This is the continental crust, the brown one. But then the blue one is the oceanic crust. These are the 2 crusts that would form subduction.
We'll talk about subduction when we talk about plate tectonics too. One planet gets recycled underneath another planet or plate. Sorry. Okay, mantle. We cannot go to the mantle, but small pieces of mantle get erupted from volcanoes. So we have been able to look at pieces of mantle. This is kimberlite. Have we ever heard of kimberlite before?
No, not part of it.
Okay. Kimberlite forms really deep in the mantle. It'll find a place in a volcano that it can escape, and it will come out. And this is where we get a lot of our diamonds. Kimberlite contains a lot of diamonds.
So like the middle of the earth like has like a lot of money in it basically?
It forms the diamonds will form in the mantle, yeah, and they'll come up with
Diamonds?
Oh, so where do they come up at?
A lot of them are in South Africa. A lot of the diamond mines in South Africa are around volcanoes.
Diamonds aren't actually that rare. It's just they restrict how much that they're putting out for the public, so they're worth more.
Well, and there's different quality too.
Yeah, there's vaults full of them, but the family that owns most of the mine, they want to make more money, so they're not giving out as many. They're only giving out a certain amount.
The mantle is hot, solid rock, and we know it's our second layer. The composition is known because of seismic waves, meteorites, and heat coming from inside the earth. And the rock that forms most of the mantle is called peridotite. It's kind of a green color. It's kind of pretty. but it is unusual at Earth's surface. In the mantle, you get heat flow. Have you learned conduction, convection, and radiation?
Yes, we did
Okay.
that.
So conduction is flow from warmer to cooler, and it happens as atoms collide into each other. They have to be touching, correct?
Yeah.
Okay, conduction is when things have to touch. Convection is not, and then radiation is not. The lower mantle is heated by conduction from the core. What happens when things get hot? When air
They
gets
melt.
warm.
They melt.
What if it's air?
Oh, it condenses. Doesn't it?
Not when it's hot. It expands, it rises, and then when it cools off, what does it do?
It blows.
It lowers. So you get this rotation of hot, rise, expand, cool, condense, and it sinks. And it keeps doing this over and over. The material, of course, cools and sinks. So convection, the currents in the mantle are called convection currents, are the rising and sinking of warm and cooler material.
Convection currents form because of differences in density. You've heard of less dense material rising and more dense material sinking. Here's a convection current. Warm air rises because it's less dense than the cold air.
It's kind of hard to see, but that's a glass tube that's going around. It's not hot enough or close enough because hot air rises, right? So hot material expands. The heat pump in your house works kind of like that. So at the core, this is the densest part. We said it's iron and nickel. We know that it's metal. We know the inner core is solid and the outer core is melted because we've looked at meteorites and we think they're similar. We've calculated the density of Earth from the rotation, and of course we know seismic waves give data also. Liquid that is convecting that rotation of hot and cold is what we have to have for our magnetic field.
Earth measures more than 12,000 kilometers in diameter. But our direct knowledge of our planet extends only to its outer layer. In fact, up to now, no drilling has penetrated more than 15 kilometers into the ground. With indirect observations, such as the study of earthquakes, scientists have been able to establish a model of the interior of the planet. The outer layer of Earth, composed of solid rock, is called the crust. At a depth of 10 to 70 kilometers, the crust is very thin on the scale of Earth as a whole. The crust sits on the mantle, which takes up 80% of the planet's volume. The upper part of the mantle is rigid, while at greater depths, the rock is partially melted at temperatures as high as 3,000 degrees Celsius. Finally, the center of Earth is called the core. It is an extremely dense area, composed mainly of metals, where the temperature is above 6,000 degrees Celsius. Part of this heat, carried by the slow movement of molten matter, rises toward the surface and warms Earth's crust.
Okay, so lithosphere and asthenosphere. Can you think of a solid that can flow?
Solid that can flow?
Uh-huh.
We can
Wood.
flow.
Wood.
We're not solid though.
Wood.
Wood?
Wood.
It can flow?
Somewhat. Driftwood, yeah.
Wood.
Not float. Flow.
Oh, I thought you
like
said float.
pour.
Toothpaste.
Toothpaste. Okay.
Sand.
Sand cannot flow. Sand is solid. Like if you melt it, it becomes glass. So toothpaste is a solid that can flow, but it would only be similar to the asthenosphere if it was ultramafic and hot. It's not.
And this is where I thought last time, wouldn't it like be a liquid? It's like, doesn't it feel like it'd be a solid?
It technically is a colloid. Have you talked about colloids
No,
before?
like both?
Yeah.
So, what, like, have scientists, like, ever figured out, like, what ooblek is? Because, like, at one point it's a solid and at one point it's a liquid.
It's colloid.
What is?
Oobleck.
Oh.
All right, so the lithosphere, crust and upper portion of the mantle that behaves as a brittle, rigid solid, about 100 kilometers thick. It does break when it is stressed. Earthquakes are stresses on the lithosphere. They build up enough pressure, it has to crack because that pressure has to be relieved. This is what forms your tectonic plates. The asthenosphere is the solid upper mantle, so it behaves as plastic. And again, the lithosphere rides on the asthenosphere. This is what makes the tectonic plates move. Questions so far about Earth structure? All right. You are going to label and color another Earth diagram.